In this video I have another piece of test equipment that came with that oscilloscope. Is it Kikusui Electronics Corp Japan PLZ300W electronic load. So these are great if you want to test batteries or power supplies and stuff. You can set the load to a certain current draw, and this thing just basically acts as a dummy load. So if you want to say check the ampere hour rating of a battery, well, it should deliver so many amps for such and such a time, and this is a way you can set it up to a certain current draw and then see if it lasts that amount of time. So we've got switching mode only, not sure DC input, so that's just basically what you put on your power supply. Looks like load on off switch, power, current monitor, amps ohms preset, input power, 100 hertz as function. Not sure, it's got some sort of, I think some of these you can actually modulate them as well, so the load goes up and down or something. Looks like it can take up to 60 amps. Constant current. And I'm not sure what CR is. Resistance. Constant resistance maybe, don't know. Looks like we've got some sort of 8-digit. Another one, oh sorry, 7-digit. 7-segment display there, another one there, so maybe that's amps. So I've got amps / ohms, volts / watts. Is that some sort of, I think that's a LED bar graph. Probably quite an expensive bit of equipment in its day. I actually started building the Electronics Today International, I think it was. Had a project to build one and got most of it built, but never really had a use for it in the end because I sort of got more into repairs than any building and experimenting stuff, so it ended up getting tossed in the scrap metal. I think unfortunately it was only like a home built case out of some second-hand bits of aluminium and heat sinks and whatever. Looked quite good though. It was set up quite nicely. I think 2 heat sinks down the side, like a big power amp or something, a couple of old aluminium clocks that I cut for the top and bottom panel, and it had I think a blue back and front out of steel that came out of a photocopier or mainframe computer or something. I think the heat sinks were big ones out of an old mainframe computer power supply. And it was going to be quite a nice little unit, but unfortunately time got away from me and it just ended up being in the way, so I decided I wasn't ever going to use it and chucked it away. Or sold it for scrap. I think she just went in the irony alley bin or something. Bit of a waste, but it's nice to see a proper professional one. And yeah, they could certainly, there are certainly occasions where you'd like to load up a power supply or something. It looks like this is an ex-Telecom one. Bent there, ding there. Some of the back panel's not looking as pretty as it should. There used to be a plastic cover over that, which is now broken. Not sure what it has 15 connections there for. Looks like we also got DC input here, times 10 times 1. Not sure, that's broken as well. And the cord's been cut. Whether that was the tip shot or not, I don't know. This has probably been pulled out of the scrap metal pile or the actual rubbish pit. I'm guessing going by the condition, and going by the condition this other distortion meter or whatever it was, old AWA thing. But we'll open it up and have a look. I just wiped the worst of the dirt off this. It smelled a bit like linseed oil or something, so maybe it's been sitting in someone's workshop for years. May well have been an ex-auction, or maybe it's an ex-employee or something. But we'll have a look inside it anyway before we hook the cord up and just see what condition it's in and what's actually in one of these things. The one I was building, that ETI one, was just a bunch of transistors on a heatsink was what dissipated the load, I think. They just put a variable transistor sort of conductance across the load and to ground, maybe through some resistors or something. I would assume there'd be through some resistors as well maybe. And yeah, just burn it up as heat. But at least you could test whatever it was you had without having to have a load like a motor or a lamp or something, which is another way of course you can do it. And things like for testing car alternators, they make the, what are they, a carbon pile or something, which is like a big resistive thing. But you could just wire a bunch of car headlights or something together fans, radiator fans or cooling fans, and just, you know, if you can put them somewhere where they're not annoying you and not causing any issues from heat or whatever, you could just use something else like that as a load and test the alternator, test your battery or whatever. Because I had a look, I think John Cadogan or someone did a video on that type of product from some company, and I think the cheapest one was $3,000 or something, which for the average person is not really worth spending. But here we have a bunch of 2SD797s from Toshiba, and yeah, that's possibly a resistor that's involved. That'll be a, it says RH50, I wonder if it's a 50 watt, be at least a 25 watt resistor. Looks like some wood shavings or something there, so I think it's definitely been in someone's workshop at some stage, probably just before it got chucked out. And those fancy chips in the 8-pin round case you don't see very often, like the early op amps and stuff used to be sealed in a metal box like that. That's an NEC, I guess UPC 1544, 1548 I think. Oh, we've got an ICL 7107 IC, 2 of those. Don't see that sort of thing in Japanese stuff that often necessarily. They usually have their own stuff, yeah, like there's an IR something IC there, but they're the equivalent of those digital, was it a 7106 or something, ICL chip that ran the LCD, 4-digit LCD displays. Basically a LCD driver on a chip, and that's the LED version. And I mean, we've got a bunch, oh, there's more. It's not like the output of an amplifier or something. There's another bunch of transistors, whole lot of low value emitter resistors or whatever. Big relay in there. Transformer. Yeah, another bank of transistors there. So, what's that? 6. Is there any more in there? Oh, that's what the fan will be blowing up the middle of this heatsink. It's one of those radial sort of heat sinks. Yeah, quite a nice design. So 6, 8, 12 transistors I think, if I haven't missed any. So that thing would generate quite a bit of heat, no doubt. When it's going flat out, if it can draw 60 amps and get rid of it, that would produce quite a bit of heat. Depending on the voltage, I guess. And yeah, we've got some dirt and stuff in there. Oh, God almighty, do we have some dirt in there. That'll need a proper clean out. I think that's, well, look at someone's wood chips or potting mix or something. Typical stuff that's been to the tip. If it goes in with the normal rubbish, it's full of lawn clippings and potting mix and pine bark and other rubbish that people are throwing out. Yeah, massive wad of wires come in off the positive terminal. Oh, that's just not even the main wires. Is that right? These are the main wires, these great big, so yeah, those terminals on the back match the terminals on the front. That's proper wiring. I don't know how many cores, but that's like monster cable, which is what you want to see. And then there's a bunch of smaller, or 4 smaller wires going to this relay, I think, yeah. Oh, 2 relays maybe. It's like a double relay. What are they switching in, these white wires? Maybe they switch in other banks. There's actually a massive stud mount diode on the back of one of those terminals, so it looks like they've polarity protected it, which is good to see. Yeah, very nice. And yeah, very nicely built generator. I don't think the back one's got polarity protection. Oh, there's another one of those big resistors, so those 2 resistors feed from one of these wires by the look of it. Well, they 0.023 ohms. Wow. That is a very low resistance. They might even just be shunts to measure the current, because that's very low resistance. Not going to do much in itself. but I guess when you're talking these sort of currents, and multi-turn pots, small relays, millions of trim pots in here. Oh, we've got another one in a socket here, ICL 8013. I wonder if that's some specialised chip for doing something like this. Because I built a Australian Electronics Monthly watt meter thing for measuring 240 volt appliance wattage use, and that had a similar kind of packaged oddball chip that was made specifically for the job in it. And this has kind of got purple filtered on the front. Oh, it's loose too. Yeah, it is too. It's one of the ones you used to see that occasionally. Instead of red filtering perspex, they actually had purple. And it's kind of red, but more, yeah, on the purpley violet end of things. But anyway, that's enough looking at things. Everything looks fine in there. I'm just worried that fan and stuff's full of stuff. A bit of it might come out or blow in, whichever way that fan goes. If it's got more potting mix or whatever that stuff was. But I think we're safe to plug it in and switch it on and see what it does. Does this thing actually have a 240 volt fuse? Not that I can see. Unless they didn't have it on the front panel, did they? And yeah, nice vernier. It's got one of those nice vernier sort of drive setting things. What does that actually do, if anything? Not sure. That's probably on a multi-turn pot as well. Yeah, we hit one end. Something's clicking around there. Does that reset it or something? No. Oh, so maybe you've got to do all these turns and that's like a bigger reading, I guess. These are just the fractions of that reading. So you can really dial that in nice and precision. But yeah, I'd hate to think what one of these things costs new in its day. Not something you see around very often at all. A very specialised sort of piece of equipment normally. Mainly probably because of the cost, so only a few people could justify buying them. More a quality control type device or research and development type of thing. But I guess I could see Telecom Australia might use them for battery testing or something. Or maybe testing if the phone exchange can provide certain current or something, who knows. And it's got one of these weirdo European colour-coded things, but I think Earth is still the same. That's the main thing. But we can check that to chassis. Better do so. I really don't like these sort of colour schemes because I'm so used to the Australian one. Well, ours is now the European anyway. We used to be red and black, and then we went blue and brown. Oh, there's the mains fuse board. Look at it, I can see one on 0.5 amp, but it'd have to be the mains or something because nothing else in here is that low current. Let's see, does that... Yeah, that's a mains fuse. That's connected to one side of this. So at least we know there is one and it's not blown. Okay, let's... This is how it has a power switch. Well, it tried to switch on. I don't tell me the power switch is dodgy. After all that. Load on. I'd say that's possibly working. Actually looks like a sharp television power switch. I used to have a pile of those things, but I doubt I got one in stock anymore, but the latch has gone on that. Surely that's not all that's wrong with it. The other switch is on the same bracket. Oh, hang on. Now it's working again now. Wonder if there's a bit of that dirt in there. Goes to show, press on it enough times, it might start working again. Okay, constant voltage. Switching. Oh, do they even work? That is rather tight, but it was just at one end. Current 2. Still internal, change something around there. Oh, there's our LED level meter. Goes up when we press that. Or LED bar graph, I should really say. Amps, ohms. I guess we could hook a power supply up to it and see what it does. Let's see. DC. Which settings which? Oh, here we go. In and out. Out is DC, internal. So neither of those lock. Are they meant to lock on? I don't know. Current monitor. Current resistor. Do we just turn that down to minimum? Out it's in manual, or in is manual switch. Oh, that might be the current setting. Current 1 / resistor, current 2. CV mode, frequency, duty. I saw something about constant current somewhere. 4 to 60 volts and 0 to 60 amps it takes. Well, I'm going to turn my power supply on and maybe hook it up and see if anything happens. I hear a relay click. 24 volt watts. Oh, so it's 24 volts coming in, which is what the power supply is putting out. Oops. I'll load on. That would help. Still nothing happening. Oh, here we go, something. So the voltage is dropping. Oh, here we go. We're on current 1 mode, so we're pulling an amp. Looks like the meter's out on one of these things. Probably my bench supply. So we're testing it up to 2 amps. Yeah, that meter's a bit low, I think. And we can just keep cranking this up. It's showing the wattage. I'd say this thing probably works. Let's pull on a constant 3 amp out of the power supply at 24 volts. Let's go to the other mode, same sort of thing. We can just tweak it up a lot quicker. 4 amps. Ah, nice. Constant resistant mode, not sure what that does exactly. Oh, let's go back on that mode. So constant, I'll have to read the menu on this thing, I guess. Oh, this is the CC range. Oh, that's pulling constant current, alright. And that doesn't look like it changes. That's pulling everything the power supply can deliver. internal. It's doing something. Something's flicking here. I think, yeah, I can see the meter on my power supply is just vibrating. So that is a fluctuating external. So you want internal. That turns it off. That's at 1 kilohertz. Oh, 10 to 100. Oh, is that? Oh, here we go. We've got the frequency adjustment. Oh, yeah, that speeds it up. That slows it right down. Oh, yeah, we can turn the current up. So we've got an amp. Doesn't seem to flick around as much as that at that current. As I go down lower, maybe the power supply doesn't regulate as well down low. So that would probably test the regulation out a bit. Duty. Turns it off. Ah, cool. Oh, that's kind of a fun toy. It actually seems to work, so I might just put a new power cord on this thing. Let's shut it up. But that does exactly what you would expect it to do. But yeah, it would be nice to be able to test batteries and stuff with this thing. That's one thing I could definitely use it for, probably more now than in the past. And yeah, it's not spitting bits of wood chip and stuff everywhere, so fingers crossed they're out of the system. There's bound to be a few more in there. Now, how does the power cord, what's it going along behind these big cables? Kind of feel bad touching this thing, but of course there's no charge caps or anything in this thing. It's not a power supply. But I can't help thinking that it could be. Yeah, it just looks like that sort of internals. So the two power leads go where? Up into this harness or something, is it? No. The earth comes up, it looks like it probably goes to the transformer or a bolt near it. Yeah, it goes to the terminal there, which is an absolute pain to get to. You'd have to take this whole board out, which, to be fair, I think that board comes out reasonably easy. 4 screws, and it probably hinges up and pull those plugs. And I can't quite see. One of them must. Yeah, one goes to that fuse holder, the white wire. The neutral comes up. Oh, the neutral goes to a ceramic feed through, which is slightly broken there. So if I can get the mains cord to those 2 points, and I think the earth wire will just join it on somewhere. I'm highly tempted just to do it just inside the back panel here, to be honest, rather than messing around. But it would be nice. See, they've just ran an extra length, and I guess to keep the cable away from these transistors and stuff, they've looped it back over and back around. But yeah, 2 points are easy to get to. It's actually, no, it's just an insulated standoff, I think, but it goes to a capacitor, no, varistor maybe. Then it's got surge protection, then a little orange wire disappears off to the main switch. So they're switching that one, so that must be, so the black is actually not the neutral, I'm looking at it as the neutral, that must be the active. Yeah, brown wire comes back and goes into a transformer. Oh well, that was a nice simple one, so we'll just put a new power cord on that. And it looks like it's simple enough. Like I said, the earth wire, I don't know that I fancy going all the way. I can probably just put it through this panel, join it here. Why they didn't use the closest screw, I don't know. I guess because it's got a plastic clamp on it, and you don't want to put plastic where you're clamping earth wires and stuff down. If something gets hot and melts, that'll probably ruin the connection. It's got the potential to, so they always recommend not clamping anything plastic in the sandwich of stuff where your earth is. Be a pretty strange world where the earth gets hot, but someone somewhere probably experienced it once, and that's why they have standards like that. And we're going to get this cable clamp grommet. Hopefully we can just squeeze it and get it off there. It's trying to come. Here we go. They made the hole the right size on that one. Usually they're the biggest pain to get out. So I can probably actually just unscrew my new power cord and pull that through. There we have it. So I'll just hook a new one of those up. I guess what I could do, does it need a big long power cord? Anyway, I'm almost tempted just to put a plug on the end of this now that I think about it. It's a bit short really, but it's only going to be used in a workshop near a power board most likely. I think I'll put a longer one on. But that's that device. So maybe I'll try it on a battery or something at some stage. I've got a lead acid 5 or 6 ampere hour battery or something. It'd be interesting to charge that up and try it out. But for now, that's all I'll do with this one. So thanks for watching.